All right, in this video, we're going to look at standard A10E, which is basically factoring trinomials. Okay, so we're going to factor trinomials in these problems. So in this first one, once again, I want you to try to answer it using whatever method you want, and then I'll walk through a couple of strategies for solving this. This is basically, what is this expressed in factored form? In other words, let's factor this polynomial. And so the way that we factored it is we first looked at the product of the first and the last term. So a squared times negative 21 is negative 21a squared. And we're going to end up looking for two numbers that multiply to give us that. And then I want those same two numbers to add to give us negative 4a. This is the first step in our factoring by grouping, and I got that negative 4a because it's the middle term right here. And so I'm thinking two numbers that multiply to give us this but add to give us this. So I got to think of my factors of 21 and think of which of those can add or subtract to make negative 4. Actually, I'll make, so if you're looking at this, you should be thinking, okay, well, I know that 7 and 3 are factors of 21. And so I just got to figure out, I know that one of them is going to be negative because I know that their product is a negative. So either the first number is a negative or the second number is a negative. Either we have a negative 7a or a negative 3a. And to figure out which one, I just got to look at my second little equation down here. And I know that they need to add to make a negative 4a. It's that negative 7a that needs to be negative. And so the whole reason that we do that is I'm just going to copy down my trinomial right here. Is we do that because that tells us how to break apart this middle term. We want to rewrite that middle term as two different terms. And we've learned that I'm going to rewrite that as negative 7a plus 3a. And then we still have our minus 21. Now what I'm going to do is I'm going to do the grouping. I'm going to look at these two terms and find the GCF, and then I'm going to look at these two terms and find the GCF. So I see right here, there's a 7 here for a coefficient. This is a coefficient of 1, so there's not really a coefficient common factor. But if I look at the variables a squared and a, those both have an a in them. So if I were to factor an a out of those two, in other words, undistribute an a, that would leave me with a minus 7. And if you weren't sure that these two terms are equal to this, just check it by distributing back in. A times a is a squared. A times negative 7 is negative 7a. And so I've kind of factored my first two terms, and there it is. And now I'm going to do the same thing right here. Okay? 3a and negative 21. So I'm trying to think of what would be in common there. It looks like they don't both have an a, because this first term has an a and that one doesn't, so I can't factor out an a, but this has a 3, and then I know that 3 is a factor of 21 as well, so I'm going to actually factor out a positive 3, and that would leave me with a minus 7. Once again, I can check by distributing that 3 back in there. 3 times a is 3a, 3 times negative 7 is negative 21. And now look what I have. I have a common factor in each of these terms here. And so that's, by the way, that's how you're going to know you did it correctly. Your value left in the parentheses should be the same. If it's not the same, you probably messed up somewhere. But now I can basically factor that a minus 7 out to the front. Consider this like it's its own number, like it's just a single value here and a single value here. Since it's common, I can factor it out to the front, and that leaves me with a minus 7. And then when I factor that out, I'm left with, do that in a different color, I'm left with a plus 3. So our answer would be a minus 7 times a plus 3. Okay, H. Now, I want to look at another way of doing this, because I'm not against, kind of problem solving to get it right. If you had a brain fart and had no idea how to factor this polynomial, if you understand the relationship between factors and a product, we should be able to answer this. I can go through my answer choices and just multiply them back together. If I were to come to this answer choice and I were to just multiply a minus 7 times a plus 3, well, a times a is a squared, a times 3 is 3a, negative 7 times a is negative 7a, and negative 7 times 3 is negative 21. After I combine my like terms, I can see that answer choice H, when I multiply it back together, is equivalent to this. So I could have taken my answer choices and worked backwards to get here. So don't be afraid of doing that. answer choices F, G, and J, if you were to multiply those back together, would not give you this same trinomial, so you would know they are not the right answer. Okay, let's go to our next one. If x minus 3 is one factor of x squared plus x minus 12, what is the other factor? Well, I'm going to solve this by factoring, but based on what we did on our last slide, couldn't I just take x minus 3 and multiply it? Like, couldn't I do, we know x minus 3 is one factor, right? So couldn't I just take each of these and multiply them by x minus 3 to see which one of those would give us our original trinomial? So I want you to know that you can do that, okay? But that being said, I'm going to solve this by factoring. Once again, we got to figure out how to rewrite our middle term. So in order to do that, I'm going to multiply my first and my last term, the x squared term, and the constant, and that's going to give me negative 12x squared. So I'm going to look for two numbers that multiply to give us that, and two numbers that add to give us 1x. So I want to think of my factors of 12, and the first thing that pops into my head is 6 and 2, but I know that there's no way to add or subtract 6 and 2 to get a 1, so I don't like that. What about 12 and 1? Well, there's no way to add or subtract 12 and 1 to make 1. So then I'm thinking, okay, well, what about 4x and 3x? Okay, I think those are going to be our values, and we know that one of them has to be negative because they multiply to give us a negative. So the question is the 4 negative or is the 3 negative? And hopefully you're saying the 3 is negative because they have to add to give us a positive 1. If I put my negative sign on the 4, that would give us a negative 1x. So now we're going to rewrite our trinomial. It's x squared plus x minus 12. And we're going to rewrite that x as what we just figured out, 4x minus 3x. And that's still got my minus 12. Now, I guess I can put a plus sign right there. Now let's factor by grouping. I'm going to look at my two little groups here. The GCF of x squared and 4x is x. And once I factored that out, that would leave us with the x plus 4. I see if there's an x in both of those, so I factored it out to the front. And we do the same thing here. Now, one thing that's important here is if this term on the left, whenever I'm factoring out my GCF, is a negative, then I want to factor out a negative. So if I'm looking at what's common, they don't both have an x, so there's not, an x isn't in the GCF, but if I'm looking at 3 and 12, the GCF there is a 3. But since this first term is a negative, I'm going to factor out a negative, okay? And then if I factor out a negative, that's going to leave me with x plus 4. If you're confused about how I got that x plus 4, remember we can just multiply this back in there. Negative 3 times x, negative 3 times 4. I see my value in parentheses is common, so I'm going to pull that out to the front. And what I'm left with inside is x minus 3. I didn't do so good with my color coding here, so forgive me. And look what we're left with. This trinomial in factored form is this. So they're telling us in the problem that x minus 3 is one factor. Check, that's what we got. So x plus 4 would be the other factor, D. Now I've got two problems here, and they're both on the same slide. And so what I want is I want you to recognize that there is a pattern in these problems. And so this is a special pattern, the way that these binomials are set up. And this is an important relationship in algebra and really in a lot of math. And so what is that pattern called? Okay. Hopefully you're saying, oh, hey, I recognize that. That's called a difference of squares, because it's difference because it's subtracted, and it's squares because these are both perfect squares. X times x is x squared. 7 times 7 is 49. Here, these are perfect squares because 6x times 6x gives us this, and 7 times 7 gives us this. If we have a binomial in this form, we have a shortcut that we can do. Now, keep in mind, if you're not comfortable with the shortcut, I can always factor this by making my middle term a 0x, because I can insert a 0x without changing the value of this. I can do the same thing here and make it 36x squared plus 0x minus 49, and then we could factor these the same way that we did on the previous problems. However, if you know the shortcut, you can jump directly from here to your answer. And so the answer to this one is J. And so basically our shortcut is this. Once again, if it follows this difference of two squares pattern, I can take the square root of the first term, the square root of my last term, I add it once and I subtract it once. Once again, it's kind of nice because you could also take each of these answer choices and just multiply them back together to see which one gives you this. That's always a good option for a problem like this. But that strategy kind of hits you, you have a little bit of a problem when you try to do it here, because here on this problem, they only give you one factor. So you wouldn't be able to just multiply them back together with anything to get this. So let's use that difference of squares shortcut. So once again, square root of 36x squared is 6x. Square root of 49 is 7. We're going to add it once, we're going to subtract it once. So which one of these is a factor? Well, I don't see 6x plus 7 anywhere over here, but 6x minus 7 is answer choice D. Okay, we've got one last problem. Now, the tough part about this problem is that they don't give you the other factor. The answer choices don't have a second factor. The problem doesn't tell you what one factor is, so we're going to have to factor this polynomial. And so let's do it real quick. So my first thing is I'm looking for two values that multiply to give me a negative 6x squared. Once again, I got that negative 6x squared because I multiplied the first and last term. And I want those same two numbers that when I add them to give me negative 5x. So I'm thinking about those two numbers. Hopefully you are saying it's going to be some combination of 1x and 6x. Now, in all these examples, our middle term has been negative. That won't always be the case, but if that middle term is negative, that means, in all these problems, this value has been negative. I take that back. And so we know that one of these two numbers is going to be a negative in order to give you a negative product. And so the question is which one? In order to make them add to make negative 5x, you know that's going to be the 6. The 6x is what's going to have to be negative here. And so I'm going to write out my trinomial again, minus 5x minus 6. But the whole reason we did all this stuff is so we know how to rewrite our middle term. We know it's 1x minus 6x, and I can bring down my minus 6. So let's factor out our GCF of each group. In my first two terms, it looks like what is in common is an x. In my second two terms, there's not an x in common, but there's a 6 in both. And once again, since this is a negative here, we're going to factor out a negative. And keep in mind, if you're factoring out a negative 6, it's like you're dividing each of these terms by negative 6. Negative 6x divided by negative 6 is x, and negative 6 divided by negative 6 is 1. It's like we undistributed that negative 6. Now I see x plus 1 is common in both of those. What we're left with is, after we factor that out, is x minus 6. So it looks like if I'm looking for which expression is a factor, I don't see this x plus 1 anywhere in here, but I do see the x minus 6. That's answer choice A. So on most of these questions, just to summarize, we can find some way of working backwards and kind of multiplying our answer choices together to get the answer, but sometimes they'll ask it like this, and we pretty much need to know how to factor. There would be a few ways to get around this without factoring, but they're a little bit complicated. If you want to know what some of those are, come see me sometime at tutorials, and I'll walk you through those.